Good morning, class. This is Mr. Roberts at Shasta High School. And to start today, I've got three problems that I am just offering up as an opportunity to practice. So if you want, pause the video, transcribe those, copy those down, and do them. I will reveal the solutions actually just answers to these at the end of the period. So let's start. Today, we are in 522, and the title of today is How Do Arithmetic Sequences Work? Generalizing Arithmetic Sequences. So, yesterday and on Friday both, we took a look at two types of sequences in particular, arithmetic and geometric sequences, and let's review them real quickly. One of the things that's true about all sequences is that they are just an ordered list of numbers. So I can take the ordered list and write it down into a table. But when you look at the ordered list, you're like, yeah, but that doesn't have an X and a Y. But because it's an ordered list, we can always talk about the first term. So in any ordered list, we have a first term, we have a second term, a third term, a fourth term, a fifth term, a sixth term, a seventh term if we want, right? Oh, look at this is reading my mind. So it doesn't matter what sequence is. It doesn't matter if it's arithmetic or geometric. The very first number I see listed is the first term, second, third, fourth, fifth, sixth, seventh. And then I have the values that I see in the list. So, for example, if I see the list that starts at 8 and then goes to 11 and then goes to 14 and then goes to 17 and then goes to 20, hard to see those numbers, but I can come into Desmos, of course, and I'll just shrink down the X values. Oh, what a beautiful little list. Look at that thing, right? And I could see, I think I can keep going here because it looks like every single time I go down the list, I just add 3. So I can add 23, I can add 27, right? No, I'm adding 3, Miss Roberts. I can add 26, and then I can add 29. So they're nice. They are clearly a linear pattern, and in fact, I think I could ask Desmo to give me the equation of that line if I wanted to get this in the form y equals mx plus b. So that is a that is an arithmetic sequence. Arithmetic sequences occur when we have a common difference between the terms, right? The terms are all increasing or decreasing by the same amount. Contrast that with a geometric sequence. We can start with something like, oh, I'll say 2, 4, 8, 16, 32, 64, 128. So this sequence gets to where you very quickly can't see the values. I can drag this down a little bit more so we can see a few more of the terms. But you quickly see like, oh, this is doing a different thing, right? This is an exponential curve. Well, it is. I shouldn't maybe have used that term yet, but it is a geometric sequence. A geometric sequence occurs when we see that we're multiplying by the same value to move forward, right? I keep multiplying by the number 2 in this case. This is a geometric sequence. So we have arithmetic sequences and we have geometric sequences. In the previous lessons, we learned how to identify arithmetic and geometric sequences. Today, you'll solve problems involving arithmetic sequences. Use the equations below to help your team the questions below to help your team stay focused and start mathematical conversations. What type of sequence is this? How do we know? You're going to be presented with sequences often. What kind is it? How do we know? How can we write the equation for this sequence? Is there another way to see this sequence? Learning the languages of sequences. So this is a lot of vocabulary in here. Sequences have their own notation and vocabulary that help describe them, such as term and term number. The questions below will help you use this vocabulary and this notation. Consider the sequence -9, -5, -1, 3, 7. As you complete questions or parts A through I of this question, so we're completing A through I, and I want you to refer to this sequence. Is this sequence arithmetic, geometric, or neither? How can you tell? What is the first term of this sequence? What is the sequence when the sequence generator adds a number to each term, the value that is added is known as the common difference. Okay. Is the difference between each term It is the difference between each term and the term before it. What is the sequence generator? So this is nice. It tells you what the sequence generator is, and it tells you what we call it, a common difference. So the question here is, what is the sequence generator, right? What are we adding? What are we subtracting? Record the sequence in a table. Remember, a sequence table compares the term number n to the value of each term. So although the sequence itself doesn't have values, remember the term number. So we have a first term, a second term, a third term, etc. So that's what they compare. Record the sequence in a table. Remember, yeah. Okay, graph the sequence. Should the graph be continuous or discrete? Why? How is the common difference related to the graph? Okay. Why does this make sense? So the common difference has an attribute that shows up in the graphs. What is that? Write an equation to model your sequence. Begin your equation with t of n. So the input for this is the term number. So when you put in the number 1, right, it should give you the first term. When you put in the number 2, it should give you the second term. What is the domain of the sequence equation that you have written? The domain, again, are the input values. In this case, the input values of n. What is t of n? If n equals 0. Okay, so we don't talk about the 0th term, but if we did, right, if n was 0, what is t of n when n is 0, and how is that represented in our sequence equation? So great to have people to talk about this. This is not a difficult problem, especially have people to talk to. So I do recommend that you guys are in conversations with each other, get together in a group, and think through this, not alone. Let's move on. 58. Throughout this course, the initial value, the starting point or 0th term, will be used for t of 0. And this number will not be listed as part of the sequence. Okay, so t of 0 is not going to be listed throughout this course. T of 1 is the first term, and it is the first number listed in the sequence. So when I look at a list of numbers that are a sequence, right, I understand that the first term is t of 1. T of n is called the nth term of a sequence. So t of n, right, if n was 1, it would be the first term. When n is 2, it's the second term. When n is 3, it's the third term. What is the 0th term? What is the first term? What is the common difference? So we're considering the sequence. What's the 0th term? That is, what's the term before the terms I see listed? What's the first term? And what is the common difference? Write an equation for t of n. Verify that your equation works for each of the first 4 terms of the sequence. So you'll know you have the correct equation when you plug in 1 and it gives you -4. When you plug in 2, it gives you -1. When you plug in 3, it should give you 2. So you'll know that it works. That's how you would verify that your equation works. Is it possible for t of n to equal 42? Justify your answer. So think about this. If you've got a sequence of numbers, not every number is going to be hit by that sequence, right? Because we have this domain restriction. Our domain can only be those counting numbers starting with 1. So are we going to hit 42 or are we going to jump over it? So you have to think about the particular sequence that we're looking at here and decide whether or not it'll hit it or it won't. For the function f of x equals 3x minus 7, is it possible for f of x to equal 42? Okay, so this is a different question. It says, so for this function, not a sequence, for this function, can I get a value of x that would equal 42? And remember, the difference here with this function versus a sequence is in a function, there's no restriction on the domain. There's nothing that says that x couldn't be, for example, a fraction or some decimal value. Whereas in a sequence, the only allowed inputs into the sequence would be those counting numbers. So then jot down a difference between the two. Okay, I'm going to wrap this video up at this point and kind of get out of the way. But I do want you to go all the way through question 60, I think it was 64 or or 60, not 63, no, 64. I want you to go through 64. So this will be, it's a fairly long assignment. That's why I've actually doubled the points for this assignment. But go ahead and work through the remaining problems here. Please see me today after school. See me online. If you have questions about this, we'll be discussing this on my talk. I'll be talking about the answers to this on my talk on Thursday/Friday. But every single one of these, I think, as individuals and collectively as groups, you should be able to work through. I have good confidence in you as a class and your ability to communicate with each other. Please reach out to other members of your class. Don't try to do all of these alone. But this is some interesting stuff. This question right here, 59, I love. She's building the sequence and she knows that she wants the fifth term to be 11 and she wants the 50th term to be this. So if you think about it, I've got an input and an output, another input and another output. Can I create an arithmetic sequence here? Essentially, can I find an equation of a line that'll hit those 2 points? Excuse me. And as promised, here are the answers to the 3 questions I posed at the beginning of today. So it gives you an opportunity to check your work. My preference is always having answers that are expressed as reduced fractions and not even mixed numbers. I prefer improper fractions. So negative 21 fifths and 1/6 are fabulous. And then for 35, the answer was 15. All right, guys, so wrap this up. I am doing a weird thing as far as the due dates go. This assignment will be due on Thursday at 11:59. And the assignment for 5.2.3 will be due Friday at 11:59. And the reason for that is I just want you to kind of be able to manage your time and prepare for the test that's coming up on Thursday, Friday. But I do caution you, I would work on a good chunk of this today. If you wait until Thursday night and Friday night, I think you'll be frustrated with trying to complete those assignments. But remember, I I have posted my test from I think 2 or 3 years ago. I've posted the solution videos for that, so make good use of those. And then the questions from yesterday and then these 3 today are good helps, good supports as you study for our test on Thursday, Friday. This is Mr. Roberts. I'll see you in class and I'll see you online.